Okay, hello everyone. This is another design review. This is for a Wolfram Institute project about hypergraphs that hopefully is going to lead to a nice, widely available hypergraph Paclet. So let us begin.
Doctor, download it first. If you want to actually evaluate it.
Oh, download this notebook. Okay. Do I have to do it in 14.2 or does it not make any difference?
Shouldn't.
Okay. And do you happen to know where I saved this before?
I have no idea.
Can somebody tell me, please?
I'll find out.
I think I'm going to create a new folder here in SW Notes called Hypergraphs. Let's go ahead and save this there. All right. Oh. Okay, so let's go ahead and get this and load it in. Okay. So let's take a look at what this is saying. So like in a graph, these are nodes and these are hyperedges, is that correct?
Yep.
Yes.
Okay. So the node 7 is a separate isolated node that doesn't have to be involved in any of the hyperedges, correct?
Yeah, you can specify a list of vertices if it contains a vertex that is not inside of any edge added, right? But it
So
assumes
if I just say hypergraph of, and then I just say 1, 2, 3, 3, 2, 4, 2, 3, 4, 4, 5, I get that. And if I say that vertex labels are automatic, I get that. I don't know quite why it changed size. That looks like a minor bug. Anybody want to comment on that? Nick or anybody else? Can you comment on why it changed size when I did that? It usually would capture the size from that output.
I know how to fix that. I can help them with that.
Okay. And we got some plot themes, I gather, here. That's fun. Do we have plot themes for graphs usually?
Yeah.
So if I say random graph, oh, by the way, you've got a bunch of background hiss, Ian, just for what it's worth. So if I say this and I say plot theme arrow, what are some plot themes here? I got a no here. We don't have a dark mode, but we have, okay. Oh yeah, we've had this, right. Okay, cool. So the default is this automatic one, which is going to have some different color for different hyperedges. Is that the idea?
Well, it's not the default actually. The default is Wolfram model right now. Automatic is previously was the default.
Okay. Well,
Yeah.
so it seems like we might, I mean, I quite like this. I think this is reasonable as the default.
That tries to mirror as much as possible the graph theme, the default graph theme.
Yeah, well, so fine. So we should make this the automatic theme, right?
It is, yeah. So
okay, but it shouldn't also be the Wolfram model theme. It should be the one that is called automatic, right?
Yeah.
And this one should be called something different, like
colored or something.
Colors. Colors.
What should it be called?
Colors.
Colored.
Or
colored, I think would be a good theme,
yeah.
a good name. And that would have a different. That would have a different color for every hyperedge. Is that correct?
Yeah.
Yeah.
Okay. And we have some palette to use for that by default.
Well, right now I think it's the default that uses for plots, right?
Well, it doesn't look like it.
Why? It's like from right to left. You see, it's like blue, yellow, green. I think it's the same colors.
Well, here, let me do it here.
Steven, I put the file path for your Dropbox in the Zoom chat for where your notes are in the previous meeting.
Well, okay, so those indeed do look like the colors. It would be nice to ask graphic design at some point if they have suggestions about this. Okay, so typically we're going to want the lines to be more intense than the hyper edges. Roger and Charles, is this your first time seeing this, or have you seen this before?
Well, it's my first time.
Charles?
Well, first time I've seen the Paclet on the repository, but first time I've been in a meeting and seen this.
Okay, fine. All right.
By the way, is there like a way to extract all the styles from the current graph plot teams? Maybe we just can simply apply them because we use the same options.
Maybe that's something for Charles and Ian to help you with. Make sense, guys?
Yep.
Charles, is there any problem with that?
No, not at all. That work.
Okay, so let me start understanding some of these things here. So let's say I put a tag on this edge that says hello. Okay, I'm not seeing that tag. Should I be seeing that tag? If I say edge labels,
Yeah.
arrow automatic.
It's edge tags, like for the graph. Automatic is just names like this.
Okay,
But you can use edge tag.
whoops. Magnificent. Okay,
Where do edge tags? Yeah, okay.
looks nice.
Makes sense.
Okay. Now, this cyclic edge thing is, so normally these things are defaulting to ordered sequences, correct?
To unordered. I think that's
I'm sorry? I
currently
thought we
it's
went through this and we said we're going to
we
use
did.
ordered sequences. Didn't we go through that last time?
Yeah, we did. I haven't changed that one.
Okay, but so they will be using ordered sequences.
Is
Or
it
maybe
possible to specify
current
edge
connect-
lists in graph using lists, or do you have to use rule or directed edge and undirected edge?
You can use lists for the graph.
What's the
So
meaning
if I
there?
say graph of 1, 2, Charles, maybe you can speak up here, please. 2, 3, 3, 1. Does that work, Charles?
Should work, I think.
Right. It's not documented, but it works.
Yeah. So this is the behavior that we matched, basically.
Okay.
I mean,
I
there's a
don't think
lot
you
of
need to
reason why it should
document
be.
this. I don't
Yeah.
think you need to document this. I think it's just something. Okay, so now here, if I say hypergraph of %13, it worked. Nice.
Yeah.
Okay, so if I say now edge list of that on Cadorus, that's nice. Okay, let's talk about unordered hypergraphs and cyclic edges and so on, right?
Mhm.
So it seems to me that we need some kind of option that is a default wrapper for the edges that defines the symmetry types. But otherwise, you give it explicitly. Now, Roger, we have some. Well, maybe you guys have. What is your scheme for dealing with okay, this edge symmetry. So that's what you have here in this edge symmetry.
Yeah, but there is a head now. It is just called edge symmetry. You can specify wrap any edge with edge symmetry and then comma an actual symmetry.
Okay, but what's
that-
the convenient?
Why isn't that head just hyper edge?
Yeah.
Because it's easier to have lists.
No, I understand that.
Well,
But
yeah, the list syntax is fine, but why not have hyper edge of a list, comma, the
I agree.
symmetry?
I agree.
And maybe even just edge, but
Well,
Sure.
if one of those things is a pure edge, that should work. In other words, in
Undirected
here,
edge or directed edge, right?
yeah, I mean, in here, if that happened to be an undirected edge, how do I make an undirected edge?
UE.
UE.
I
Yeah.
usually do that. By. Great.
yeah.
Now, are we giving an indication here when these are directed hyperedges? Why aren't we giving any indication of the direction here?
Well,
I thought
because
we were going to do that.
It's
Yeah.
defaulting to undirected.
yeah,
Right?
yeah, yeah. Right now it's undirected.
Oh, so that's wrong. Okay,
But you
so
can
then-
wrap it with a directed edge. You can just wrap that list with directed edge with a single argument. Right now, it also works.
Yeah.
So it has this behavior of like increasing arrowhead.
What do
So
you mean
that
by
it-
increasing arrowhead?
that's
Why does
right.
it do that? Why is
Because
it
like-
just an arrowhead? I don't understand.
Just
Why does it have an increasing arrowhead?
just imply the sequence.
I'm sorry?
Just imply the sequence of that there's a missing edge from 1, 3. Just imply that it's 1, 2, 3 instead of the cyclic one.
But
To
it's
be-
obvious, right? I mean, it's got
It is, but if you mix it with other cycles, it gives you a visual cue that one is directed and not cyclic.
I don't believe in this. I mean, I think we should be consistent with what we've done here. This is not. I don't understand. Give me an example where this is useful.
So if you mix, I'm not.
No, give me a specific example where it's useful. That's what I'm asking for.
Yeah.
If you
So
can
in
send
the,
it on chat.
make
Send it on chat.
a loop. Make a loop.
Make
like
a
a-
loop of what?
Like a ternary or quaternary edge with a loop, so that you have one vertex repeated. And it's directed. Make it directed. Right. Then it's like confusion can be there. It's like
I
how
see.
it
With
actually
the
goes.
cyclic case.
Yeah.
Okay.
with all-
I think we need another way of indicating that.
Hmm.
I understand. I don't think this is a good way of indicating it. We do not want our default to have weird arrows of different sizes.
yeah, and I agree. I think we need a better one as well.
Okay, so what I suggest is this. I suggest if it's cyclic, we have some kind of unfilled arrow, and if it's not cyclic, we have a solid arrow. And I would have thought we should put the arrows like we do for edges in a graph, in a default graph, we should be putting the arrows at the ends. Am I making sense?
Oh yeah, yeah.
And how about for as another option for cycles, another possibility, I mean, for cycles to have arrows sort of inside the edge and for directed ones, full arrows, just the same size.
What do you mean by inside?
So basically the arrowhead just basically missing one half that is sort of outside of the edge, just to sort of
Oh, I
imply.
see what you're saying. That's
Yeah.
an amusing idea. Do we know what the outside is in all cases? I mean, what you're suggesting is something where, I mean, to draw it, you're suggesting that we go,
So when we do these concave things, we do know it.
okay, you're suggesting we do this, and we have, it's like that, basically.
Yeah, something like that. Yeah.
I like
Well,
that idea.
I get still confused. How can we differentiate between how can we tell the order of vertices in a directed edge when it has these loops around them? It's like I'm still confused how we can do that.
I see what you're saying.
Hmm.
In other words, that it goes 1, 2, 3, 1, and how do we know that the 1 is the starting node?
Yeah,
Right?
Yeah.
So I think we
Those-
need an indication of that.
Yeah, that's why I had this increasing arrowheads for that reason.
Yeah, I understand. I think we should have something which indicates the start. Probably some kind of
But it's
something
not just
like
about this. It's not just about the start, right? It's like all the intermediate nodes also has to. As soon as as soon as there are some loops in there, it's unclear how it goes. What was the actual order of vertices?
Yeah, but that's that's one of the things with simple and non-simple hypergraphs, right? That catering for general degenerate vertices is going to make the rendering much trickier for it to be.
Now, what did that do? Hypergraph.
Just a list of vertices. Make another wrap.
Okay. Now, how do I get the edge symmetry? Oh, I can say
Just make-
directed edge of that.
Wait, why does a hypergraph with no edges not show the vertices?
No, because those were taken as the the atoms, the vertices.
Yeah.
They just weren't. It wasn't an edge. There
I
wasn't.
mean,
there was no
if
edge vertex.
you can have a totally disconnected graph that's just vertices and no edges.
Exactly. And this is the same thing.
Yeah.
That was the same thing. This was a totally disconnected hypergraph.
Yeah.
I thought it looked like there were no vertices.
No. There were vertices. The only thing was that there were copies of. I mean, what we got there was a slightly degenerate thing, which again we could have in graph. I don't know what graph does in that case. If we say 1, 2, 3, 1, why doesn't that do anything?
I think you have to do comma empty list.
Comma empty list, I think, right?
Charles, can you speak up, please?
Yeah, you have to do
Yeah.
comma empty list.
Okay, so in this case, the repeat of the 1 had no consequence, correct?
Yeah. Well, for
Yes.
hypergraph, the same thing.
And is that how we want it? I mean, in other words, that those two there, is that equivalent to graph of 1, 2, 3 without the extra 1, correct?
Yes.
Okay. All right, fine. Okay. So this incredibly confusing thing
Yeah. Yeah,
is incredibly confusing.
it is.
And I don't think there's any way we can make it less confusing.
I agree. And that's why
Maybe if you had mouse overs that highlighted the edges.
maybe.
Maybe.
But
I don't think we should worry too much about this case. But what we don't want to do is muddy up the appearance of cases that aren't this tangled. Am I
I
making
agree.
sense?
Yes, I agree, and that's why I think it makes sense to go for simple hypergraph at the level of the symbolic expression, and then basically populate it with labels, both vertex labels and edge labels, to express everything you want in terms of the rendering. In
That's
terms
fine.
of the,
That's fine. That's fine. So I think Nick's idea of different sized arrows, while clever, seems like it's just not going to lead to a good visual result. So I suggest we remove this, and we for these edges, right, we put the arrows at the end as we do for a graph. Does that make sense to people?
Yeah, that one is easy. Yeah.
Charles, anybody else? Do you want to comment on this and what you're doing there and whether you're happy with this? I mean, I think that looks just fine. I think we should
You
do
can
the same
control
thing
the
with
arrowhead position in graph, right?
Yes.
Do we? Charles, can you speak up,
Ye-
please?
I say yes, you can control. I mean, it's a style, right? You can add, edge label, edge shape, edge style goes to arrowhead.
Okay, fine.
Control that.
But generically, it's putting it at the head end, so to speak, of the arrow.
Yes.
Right, and I think we should do the exact same thing here. And in the cyclic case, because that's a fairly common case, we should. So one thing is we're not bordering these edges. In the case where it's undirected, we're not bordering the edges. Am I making sense? In the hyper edges don't have any borders on them. I don't know whether that's unambiguous. Do you understand what I'm saying?
yeah.
Well,
Nick, do you understand what I'm
in
saying?
what case again you don't want borders and you don't want them?
No. I'm asking you, are there any cases here where the lack of borders makes these pictures ambiguous? I don't know. I can't think of one immediately. So
Well,
I think this is right. What you're
maybe-
doing is, go ahead.
Well, if there's like multi edges, it can really be messy. Right?
Yeah, but I mean, look, there's messy here. Okay, so I think this idea of no bordering for undirected hyperedges is fine. I think we might want to lighten up the color slightly here. We could, that's another item for graphic design, please. Make sense to everybody?
Yeah.
What if you include an ordinary undirected edge in that hypergraph, N of 27?
Ordinary undirected edge.
Just add undirected edge of 4 or
Gonna
5.
be just a line.
Oh, sorry, it was, let me do 3, 5. Looks nice.
Is
that's
it
a
a
directed
problem
edge.
that you have that like solid blue color for the one edge, but you don't have a border?
Don't think so. I don't think so. That's a directed edge. Well, I see it's an undirected edge. I don't think it's bad. But that's another thing for the design, for the graphic design review,
Mhm.
please.
What about if there is an undirected edge 2, 3?
Yeah.
Oh, I see.
That's why it tucks in.
Exactly. Yeah.
Oh, okay.
Okay.
I'd like to argue that these should not be called undirected and directed, but instead it should be unordered, ordered, and cyclic. Because
Yes.
directed
Yeah.
hyper edges, usually you have a bipartite,
Correct.
you know, you
Yeah,
have the source and
how
the
we
target.
actually refer to them. That's how we refer to them if you want to specify edge symmetry. It's
Yeah.
just we
Okay.
have this conventional edge heads also supported and correspond to those.
Okay, so let's go through. I mean, right, that's a good convenience. It's very nice. It's what we want.
Mhm.
Okay, so now let's talk about. I mean, we got lots more to review, so we want to get through this, but we got to talk about these wrappers. Okay,
Mhm.
where is the grammar of those wrappers?
Well, they literally just correspond to annotation, right? You can use annotation wrapper and then
No,
specify.
I understand, but I want to know, how do I make what is my quickest way to make an unordered hypergraph?
Mm.
You can do edge symmetry as an option and make all unordered.
Okay, but we can't have both edge symmetry as a. Okay, so let's review what we're talking about. So we're talking about having a hyperedge wrapper, right?
Yeah.
Where that hyperedge could
I think so.
potentially be. I'm sorry, go ahead.
I said I think so.
Yeah, but so then when you say edge list, do you get? I mean, when you say edge list of a graph like this, right? If I say edge list of this, I get those kinds of edges.
Right.
Oh yeah.
Therefore,
Basically, our edge list drops all information about the symmetry, right? There's a separate option and function edge symmetry that returns like edges which are just list of vertices with the symmetry, right? So
okay, so I don't think that's. I mean, we need to think about that, right?
Yeah.
I mean, in this case, we're returning something with the analog of symmetry information, namely directed versus undirected edge here. Make sense?
Right.
I would think that, I mean, I haven't considered it closely before, but I would think the edge list of hypergraph should return a list of hyper edges.
That's
and
what
they
I
would
think
have
too.
some nice formatting.
I agree.
what
I
I-
agree with that. Yeah.
I mean, beside the formatting, there is also additional light tag. I don't know if you have it here. I saw that you have edge tag there. But sometimes you want to carry those information on the edge, right? For the
Yes.
subsequent operations.
I believe the notation they're using is list arrow tag.
Right,
Yeah.
which hopefully works for a graph as well. Okay, let's just cut through this. Okay, so I think what we want is for edge list to return hyperedge things here, but now the way that one gets, I mean, the way one turns this into, for example, a list of pairs, the common way to do that is just by saying things like list triple at this thing. I mean, we don't really have special ways to make format changes like that. So I don't know whether we want something different for here, but I think that would be okay. So assume we have hyperedge and assume that edge list gives a list of hyperedges. Am I making sense there?
Okay.
Yeah.
Is it
Mhm.
does HyperEdge also holds the tag, right?
I'm sorry?
Tag. It also holds the tag.
Yes,
similarly
it holds the tag, just like edge, directed edge of A to B to tag, right, holds the tag.
Yeah, and the HyperEdge is just a list of vertices and the tag, just 2 arguments.
I think
Or-
so, but there's also the question of the symmetry.
How would you do a directed hyper edge?
No,
Let's see.
this is a directed hypergraph.
No. There's the symmetries, which is what we've been talking about, but I think that a directed hyperedge is a separate concept that we haven't been discussing.
Well, what
yet.
is that? What is that concept?
So it's independent of whether you're considering these to be unordered, ordered, or cyclic. It's just in a directed one, you have two of them. One is the source and one is the target.
Yeah.
Two whats?
Two sets of vertices.
Two sets of vertices, or two sequences of vertices, or two cycles of vertices.
Yeah.
Oh yeah.
Okay, which
Well,
we have to represent
basically-
as some kind of symmetry, I think. I think we'd have to represent that by hyperedge, in which we'd have two sub things here, presumably.
Yeah.
No,
Yeah.
I don't think you should modify this first argument. It's just I think it always should hold the actual vertices, and then all information about symmetry is just a third argument or something, or an option. Right? That's how we represent it right now. You just have symmetry is just either.
How would you
Well,
represent the directed edge
Okay.
concept I was just
Well, it's just
mentioning?
you represent it by a list of cycles. You can represent any symmetry by a list of cycles. Like there above, you have an example of which symmetry you specify a list of cycles.
But so here,
What if you want two sets instead, or two sequences?
I mean, are you saying that cycles can be used to represent? I don't understand this.
That's a
that
hyperedge.
could be used to represent a hyperedge that is a cyclic hyperedge, yes or no?
Well, I didn't say that, but maybe that's another
Oh.
idea. Can work. I was saying
Yeah.
that if you have a hyperedge, you can annotate it with a bunch of cycles that specifies its symmetry.
I understand, but let's just go through the cases we know we need, right?
Mhm.
We need the fully ordered hyperedge.
Yes.
Right. Then we need the fully unordered hyperedge. Those should both be easy to enter.
Yeah. I
Okay.
think those are just the list with a named symmetry.
Okay, but so then in the hypergraph itself, you know, arguably what should happen is the hypergraph itself should have a list of nodes, edges, and then perhaps a symmetry here that
Yeah.
is its default symmetry as an argument.
Okay, yeah.
For all the edges.
That is
Yeah.
correct. That would apply to all the edges. So it would be something
For,
like
for all the edges that are just given as lists, right?
Yeah.
If the edge
Yes,
has an
yes,
explicit
yes,
symmetry
yes.
already, you would,
so we would say something like this. We would say unordered here.
Yeah.
Mhm.
Okay, and that would represent an unordered hypergraph, and the default would be ordered.
Could
Yeah.
graph work like this then too? So
It
that you
could,
have directed.
actually. It could. Charles, do you have any comments on that?
Well, is it needed? I don't think it's needed. So
It would only be needed if we supported the list input for syntax. Right?
yes.
So, okay, let's leave that out for now. Okay. So sorry, what happens if I try and convert? Did we try that already? If we try and convert a hypergraph to a graph,
Can I
does that
just
work?
what's the difference between ordered and unordered and symmetry?
Okay, we'll explain. Okay, so this, okay,
Well,
so
there's a
this should
hypergraph.
generate a message. Make sense? Or this should use the relatrix to break this into a graph. Am I making sense?
Yeah.
I would say it should probably use the relatrix to break it into a graph. Nick, Carlos, comments, please.
Yeah.
Yes, that's what we'll try hypergraph to graph. I think it's just we have a function that
Okay,
does.
we shouldn't need that function.
Could someone explain what the relatrix is for the
Yes,
benefit of
it's
those who
a
don't
name
know?
we invented very recently. That is the thing that it is a graph that represents the relation of the nodes in a hyperedge. So for example, if the relatrix is a complete graph, that corresponds to an unordered hyperedge. If the relatrix is a path graph, that corresponds to an ordered hyperedge. Does that make sense?
So would the graph of a hypergraph be a bunch of components? Each one is one of
Yes.
these relatrixes for each hyperedge?
Yes, it drills through to the relatrix because the relatrix is a graph. Am I making sense? Does that make sense to everybody?
Yeah. The only slight comment is that we might want that undirected edges are empty graphs, and we might want complete graphs for the special function of undirected edges that have full permutation symmetry inside. Just for, but I mean, in practice, it's what you said, just as a
Okay.
possibility.
I didn't quite understand that, but let's keep going. So
Yeah, I'm just trusting you that there's some encoding there.
yeah, okay. So then, what we're talking about here is all right. Cycles will be a way of specifying a cyclic hyperedge. There is
Well, it would also be another second argument for hypergraph, right? Hypergraph of edges, comma cycles, and then each list would be considered a
yes,
cycle.
but now I don't understand how we specify an unordered. What is the second argument that gives us? So in structured arrays, we have a symmetry specification, right? Don't we have a symmetry specification symmetric? Roger, can you speak to that,
for
please?
symmetric array? Yeah. So yes, is that what you meant? Okay, the wrapper there. But that's. But I think if you meant the arrays, this is symmetric array.
No, I didn't mean the array. I meant the wrapper.
Okay.
So what we're saying is, then if we wanted to, we could say for a hyperedge, we could say hyperedge. This is an incredibly ugly way to say this is a hyperedge. Whoops, hyperedge. That's a very ugly way to specify an unordered hyperedge. Right, guys?
Yeah.
Yeah.
And you could just say unordered there as a string, right?
Wouldn't it? I'm just guessing. Is that the same as saying that there is no permutation group? I mean, you can't permute anything.
No, you can permute everything.
The
Yeah.
opposite.
Okay. The other way around. I mean, the ordered is where you can't
That's
do
correct.
anything.
That's
Okay.
correct.
Yeah.
Okay, so in a first approximation, so this thing here represents the relatrix.
Mhm.
And we don't have a function, which we might have, that takes a symmetry specification like this and turns it into a graph.
Right.
And that would seem to me to be a useful utility to have. Maybe it's a good WFR. So in other words, from a graph, we should be able to get the symmetry specification from a symmetry specification of graph. Does that make sense?
Yeah, that would be effectively the relatrix implementation. The one comment I do want to make is that it actually makes perfect sense to think of the edge symmetries as array symmetries. This is in fact the other thing that I was mentioning in our conversation, Stephen, about the hypergraph representation of the array products and so on. So yeah, any edge can be understood as a symbolic array, and therefore any functionality for symmetry of arrays should reasonably apply well to hyperedge symmetries.
Okay, that is something we need to figure out for the future. So we have many equivalent versions of how to specify things. I mean, it is slightly frustrating to me that there's no immediate way to get an unordered. I mean, we may end up wanting to have something just like we have a directed graph and undirected graph, right? As wrappers, we may want to have
directed edge.
No, but we also have.
We have a way to turn them around. Is that what you meant? Yeah.
Yes, that's what I mean. So it may be that we'll end up needing an unordered hypergraph wrapper.
Yeah, and an ordered hypergraph.
Possibly, yes.
Yeah,
Which
possibly.
I don't think would be the end of the world to have those.
Hmm.
And that way you can always use those wrappers to get these things here.
Sure.
Mhm.
Makes sense.
Okay. Let's continue. We got quite a bit to go through here. Canonicalization. Well, we've talked about a different way to do this now as the third argument of hypergraph, so we don't need an edge symmetry option there.
So there's also the question, obviously that is now to be changed, but there's also the question of mixing symmetry types on the same hypergraph. That was one of the challenges here.
Well, but we got now a hyperedge wrapper.
Right.
Yeah.
Right. Yeah.
That's the place to put it.
Yeah. No, I
And
meant
then a
for the
better place to put it,
canonicalization.
honestly.
Yeah.
With respect to the canonicalization,
I mean, now you could do the whole relatrix thing and use our canonical graph, right?
Oh yeah, something like that we already do.
That's virtually what we do.
Just not the relatrix, but some kind of form of turning hypergraph into graph.
Mhm.
Okay. So this canonical hypergraph, then you have a
But there's something what works for hypergraphs now that doesn't work for graphs, for example, the mixing of edges so that we have multi-edges, right? Not just multiple arities, different arities, but also multi-edges.
I see.
Somehow,
Why doesn't
somehow
that work for
works.
canonical for graphs? Does that not work in the canonicalizer for graphs?
I think that it.
Well,
I think it would work.
we just don't support mixed graph yet for doing the canonicalization.
Maybe you should go through the hypergraph code. Does hypergraph work with mixed? Would it do mixed graphs for its
Somehow it
canonicalization?
does, yeah. I can't really guarantee that it works, but in the cases, in the cases I've tested, it works.
Okay. Well, perhaps Charles could look at what you did, and maybe that's something that could be used.
Mhm.
Okay. So
It simply relies on some way of turning it to it. Just
We have a general way to do it. We just didn't yet have time to do that. Right? So, including handling property, it's not just the topological structure. So,
okay, would be a good thing to get done.
Yeah.
Okay, so do we understand what the canonical hypergraph looks like? Because we're going to have to fix that canonicalization. We don't want it to change in the future. Am I making sense? I mean, we canonicalized something with hyperedge wrappers, right?
Yeah, I think so. That's the correct way.
Mhm.
So that everything has hyperedge wrappers, and we don't rely on anything. I mean, I suspect for the purely ordered hypergraph that we could drop the hyperedge wrappers, or maybe not. I don't know. Maybe we should have the hyperedge wrappers in all cases. What do you think? Probably we should have the hyperedge wrappers.
I think
the canonical
so.
form.
Yeah,
Okay.
I think we should keep the wrappers now.
Okay, Nick, do you agree?
Yeah, I do.
Okay. Okay, so now we just have an ordered hypergraph version of this.
Yeah, that's the details how we turn the hypergraph to the graph. What kind of graph you create. Structure preserving transformation.
Sorry. Say that again.
That's the structure preserving hypergraph to graph transformation. I think you used it in the physics project a lot.
Okay, so this is the way this is the node naming for the graph, hypergraph to graph, correct?
Yeah, it's ordered. It's a little bit different function, right? It's just when you turn hyperedges to vertices, which you don't want to do if you want to do the relatrix transformation, right? You just want to turn.
Okay, but what we talked about before was that just graph of hypergraph. Is that what graph to of hypergraph would always do? Even if the hypergraph, I mean, the round trip should work. If you have a graph, you turn it into a hypergraph, you turn it back into a graph, it should round trip, right?
I
Well-
don't think so. Because if you're keeping some kind of labels, then definitely, but just turning into graph objects is going to erase some information.
No, I understand, but listen to what the case I said. It was a graph. You turn it into a hypergraph.
Oh yeah, of
You
course.
turn it back into a graph. It should
Yes,
round
yes.
trip.
Sorry,
But
yes.
with this, it will not round trip.
Right.
So that's not right.
But that's not the simple hypergraph to graph function. That's why it's called ordered. This is like a different function that used for canonicalization purposes only, or maybe for something.
But so is this a user exposed function,
No.
Nick?
Well, why not? It's like
I mean, we certainly have a look. If hypergraph is one day going to be part of the system, then I mean, for the Paclet, no problem. But there's some things that we should be thinking about, tagging for future system inclusion. And I'm not sure this one is quite it.
yeah. I think it's not like a priority to figure out now what would be included in the future in the actual system. Yeah.
Well, right, but okay, so let's just understand this one. I mean, I'm kind of reviewing this with an eye to future inclusion so that we get it to that level of quality.
Mhm.
So I don't quite understand what this is and why that isn't just the symbolic
Well, we can-
hyperedge object.
Well, now it can be. Now that we figure out that we want this symbolic hyperedge, we can also
Okay,
create
fine.
these new vertices that literally this new object.
Oh,
Mhm.
just the hyperedge. Great. So
Yeah.
then the vertices here, the vertex objects can just be the original vertices.
Yeah.
So what this really is this is really, what can we call this? I mean, this is really it's really the hypergraph graph or something
Yeah, something like that.
of a hypergraph.
For example, trees and graphs, you can just do graph of tree, and it just converts it to a graph.
Exactly. But this
Maybe we don't
convert-
need a dedicated function.
No.
Say
We
graph of
need it. We
hypergraph.
don't need. That's right. So long as if you say graph of hypergraph, the question is what will graph of hypergraph do
Mhm.
if it isn't if it doesn't just have arity 2 edges.
Yeah.
Okay. If this is what it does by default, I think that's just fine.
Mhm.
Well, no, it isn't fine. It isn't. Hold on.
No.
It's not fine
No.
because this isn't right. No, this isn't right. Graph of hypergraph. What should graph of hypergraph do if it is given it is then not a faithful thing? It has to break an
Yeah.
arity 3 hyperedge into, it has to
Yeah.
break it into essentially the relatrix graph.
Yeah. So my
Yeah.
thought would be that graph of hypergraph would perform this natural arity projection operation that all hypergraphs admit, that basically essentially either shows the relatrix or builds all the SAT edges that can be built on each edge and then shows you that.
I think if you guys, if there's an interest to want to control the embedding, so to speak, I assume that there are many ways this can be done. Okay.
Yeah.
Then it's useful to have a function where you give controls for that.
Yeah.
Yeah.
But it's not
That's different.
but it's not just the look, right? I mean, it depends of what type of operation you want to do after. So you convert it to a graph to operate on it as a graph, right?
Right.
So that conversion should be useful or preserve some property you want.
Right. So there can be many that they probably preserve different things, is what I'm thinking.
Yeah.
Yeah, right. So probably hypergraph to graph is a function, and it has second argument, which specifies how to do the conversion.
Exactly.
Yeah, I agree with that. Yeah.
But just to hypergraph and from hypergraph.
You could make it from hypergraph to other things than a graph, I would say, like these arrays we're going to get to later.
Mm-hmm. I think that's
But
potentially
remember
an advantage.
that if you just wrap hypergraph around a graph, it's all good. It doesn't need any more information.
Yeah.
It's the
Yeah.
hypergraph to graph that is a lossy operation.
Yeah.
Make sense?
Yep.
Okay, let us move on. Oh my gosh. I am deeply skeptical about this. Deeply skeptical.
I watched this portion of the live stream and I was not clear what the purpose of these was, except maybe
Is
theoretical
this graph
interest.
union and graph intersection, basically?
Basically, yes. Yeah.
I think we should just make graph union and graph intersection work. Let's not mess with this. We've already, the number of times I've been bitten by the beautiful capability of taking an image and being able to, multiply something by the image. I've just, like if I take an image here, if I make, if I take this thing and make it an image, right? And then I brilliantly got that image. There's an image, okay? And I say twice that. Isn't that frigging weird?
But
I
it's
mean,
cool.
it's very cool. It's very cool. But I've had some ridiculous bugs from this.
Yeah.
So I would say don't support that initially. Unless, I just don't think we should support that initially. But graph union and graph intersection should work.
Yeah. I think
Yeah.
the philosophy behind this is, sorry, Nick, go ahead.
Yeah, we have hypergraph union, hypergraph,
Yeah.
not intersection. How we're calling it somehow differently.
Okay. I would recommend disabling this capability right now. Does Roger or anybody else have a comment on this?
I think I think if you're going to have it, I think it needs its own page to describe what the operation is.
Yeah. And the philosophy here, by the way, is that those are the analogous operations on the hypermatrices, so the analog of the adjacency matrix. So addition and multiplication really are the natural things you could do with the adjacency matrices, in this case, adjacency tensors.
But that's not quite right. Addition is not quite that, right? Does it add?
But you need to somewhere explain.
Yeah, for sure, yes.
Okay.
Yes. This needs to be explained, absolutely.
Right.
I just made it, yeah.
Okay, let's go to generation. Okay. Random hypergraph.
Well, I'm planning to completely rewrite it. Like right now, we're cheating a little bit. Like this is, yeah, we're gonna change the interface as you mentioned last time. It's gonna like take a list argument. But right now we're like cheating because like it's not trivial to generate random connected hypergraphs combinatorially. It's kind of a weird problem. So we're looking into that. Right now we're just like doing something trivial just to something to work.
Okay, so I'd like to just comment on, we've got graph distributions. In the case of graphs, our, random graph of 100, 200, there is no, that's just taking pairings, 200 pairings of 100 elements, correct? Charles and Roger?
No, it actually generates the uniform. It's doing uniform sampling of the graph from that space.
It's a default graph distribution, which has well-characterized properties.
So it's equivalent to random graph uniform distribution of 10,2, 10,20.
Exactly.
But is that, or is that not picking pairs out of the list of nodes? It's not equivalent to that?
It's equivalent, but there is a underlying distribution, statistical distribution behind.
It's like uniformly sampling from the list of all of the graphs that satisfy those
That's cool.
constraints.
Yeah.
Do we know how to do that for hypergraphs?
I just wanted to point out when I introduced random tree, it didn't have those kind of properties, and then we later fixed it so it does uniformly sample.
Okay, so there's some math here to
Yeah.
figure out of uniformly sampling hypergraphs. So maybe there's literature on this. Maybe Carlos can try and figure this out.
Yeah.
So for graph, how does it handle like connected or disconnected graphs, for example? What kind of distributions do that?
There's probably a
So
guide page with all of the distributions on it.
No, that's not what we're talking about. We're talking about, what we're talking about is uniform. You say there's a uniform graph distribution, right?
Yes.
yes.
Okay, and this is what it is doing by default, and this is pathetically badly documented. What the heck is it
Why?
actually doing? What's it doing?
It's a symbolic object.
Right. Yes. We can say, in 2024, that is bad. Yes, we are going to fix it. I mean, we wrote this function 10 years ago. Okay, so we need to fix it. But at the time, this was decent, and it kind of tried to explain what we have been doing. Right? So we just didn't come back and update all those documentation.
Okay, all right, fine. But this is, okay. This is what, this is what ultimately, what we are defaulting, what we want to default to is uniform hypergraph distribution, right?
Probably.
And we want to learn how to do that, which is a piece of math.
Yeah.
Okay, this brings us to enumerate hypergraphs. I would really like an enumerate graphs function. I have needed that so many times. Charles, what is the story with making that?
Oh, I just haven't seen a request. I don't think that should be an issue.
That'd be wonderful. I've needed it so many times. There may be some WFR functions because I've had to write it myself many times. Now, obviously, there are different types of graphs to enumerate, and I've used graph data to enumerate some of those types of graphs. But I'd really love an enumerate graphs function.
Okay, we put that into the list for the coming version.
Good. But let's be consistent then with enumerate hypergraphs and enumerate. I mean, I don't quite understand. Okay, so first of all, in random graph, let's agree. Did we already agree what the syntax would be for random hypergraph?
Yeah, I think so.
Yeah.
What is it?
Well, trying to mimic the random graph. So it's a list with a number of vertices, which can be automatic, and just a signature, which is a list of how many edges for each arity you specify, and then some options for connectedness symbol.
And then we also said the edge types, the symmetries, right?
My sense is that the more constraints you place on this, the harder it is going to ultimately be to get the distributions right.
Sure.
Yeah. But at least we care about those two constraints, whether it's connected and simple.
Wait a second. How do we get random connected graphs? Do we have a way to do that, Charles?
No, we can do that, but we haven't defined the distribution. So we kind of stop in that set of distribution. We have, I think, 3 or 4, but we haven't introduced additional ones since. So we don't have a distribution to actually work on the structure of the graph.
Okay, but if I want random connected graphs, that would be a nice thing to be able to have. Isn't that independent of, I mean, having a function random connected graph, I don't think we would want to do that through the distribution. We would rather want to say random connected graph. And I don't even understand directed versus undirected graphs.
Well, the benefit of having all the distributions is you don't need tons of different random
I understand.
graph functions.
That's just a rather, but okay, that's a separate thing to discuss. What to do with random directed graph, random connected graph, etc. Make sense? I assume Tracy is taking notes of these things that we need to follow up elsewhere for the graph theory functionality, yes?
Yes.
Okay. All right, so this is going to have, do we have somewhere a documentation of the arity syntax? Is this the correct arity syntax?
Missing the symmetry types, but yes. because now the symmetry dice would be
A third argument.
third arguments, yes, basically.
Okay.
Or maybe first argument, but yeah.
No, it's not the first argument. It's the third argument.
No, no,
Right.
what I mean is that it should be in the syntax of the tuples there in the list. The list of lists would be two unary, well, unary is only undirected, but you know, two binary directed or whatever, right? You would
How
have
would
to-
that be specified?
So I think we'd add either before the numbers or after the numbers.
No,
the
I don't
symmetry.
think so. I mean, so what you're suggesting is something like this, 2-2 directed or something.
Yes. In-
How is that consistent? Roger, Charles, anybody? Is that consistent with other things we've done? Roger, can you speak to that?
We don't have a lot of enumeration
Mm,
pieces.
I think Roger is
I
not in
don't.
the
Rem-
code.
I don't remember a case where we did something like this.
Is it correct to say that uniform graph distribution is the only one that has a simpler syntax than using one of these heads?
Did Roger disappear here?
In
I don't see him in the participants.
I mean, what do you mean by sample specification? All of them have a sample specifications.
Well, like in random graph, you can just say list m comma n, and that is like sugar for uniform graph distribution. Right.
Exactly. It's like random variate.
Are there similar syntaxes, like list syntaxes for the other distributions?
No.
Yeah.
The default case just evaluate to uniform.
Mm-hmm.
Okay. Okay. Well, so we think we have a way to, what the heck is this? What's this?
It doesn't count.
Number.
Yeah. Go ahead.
Well, you basically ignore how many vertices, just up to maximum vertices allowed for this particular specification of edges.
Okay, so that will be something we'll have to address for enumerate graphs as well.
Yeah.
I mean, probably we should remove the automatic and just let you give a single argument there, right?
I agree.
Yes.
Yeah, because that's kind of the edge-centric approach, which is, I think, the most natural.
Can we discuss the name? Is it enumerate X? Like, should I have a enumerate trees?
I think so. I think it'll be great.
Okay.
Okay, onward. This is a big wow, but it needs a bit of graphic design. Whoops, what happened here? Oh,
That's an image.
Maybe UX should look at this as well.
Yes, but okay, so those are, so what do I do here? How do I,
You
what do I
press E
E?
for edge.
I think
Yeah.
space also works, right?
Okay.
I don't remember.
Okay, now how do I join these up?
You can. Well, you have to specify them again, I guess. But
Or you can make an edge between them.
yeah,
Okay, how do I do that?
click
Well,
on the
control-
vertex 1 and 4, and then E to create a binary edge.
Charles, do you want to comment on this puppy?
No, it's the first time I see it, so I'm not sure.
Are we not
Button
have something
would
like
be
this
nice
graph, right?
in addition to the keyboard shortcut. I like the keyboard shortcut.
Yeah. I
Yeah.
think this needs a bit of a UX review. This is quite lovely.
Yeah.
And we really should have a graph draw function as well. Didn't we have that like years ago, Charles?
There was a case, and we brought it several times in meetings with you. You just rejected them, so maybe we'll do that again one more time.
Well, but it was some kind of weird Java add-on thing before, 15 years ago or something, right, Charles?
Yep. Yes.
Yeah, so
Yes.
that's not going to work. But what we have here looks much more promising.
No, we had a new version, so you probably have a separate meeting and review that again.
Let's do it. Let's do it. And make it consistent with this, and then we've got something wonderful.
Mm.
I mean, Nick has a thing in the function repository, right, for doing graph editing, correct, Nick?
Just vertex dragging. Yes, I have something like that. Drag vertex. Graph vertices.
Okay, vertex count, vertex. Okay,
I think, Nick, we now have the arity that we talked about last time, right? That we can show the arities as well.
Kinda. Well, it's just a property now, but yes, that's the same thing, I think. Vertex degree.
I think we should say, what should it be? It should say edge arity or something.
I think it's a property now, right?
No, but that's
Yeah,
not going to work.
but we
That's
want
not
to
going to
make a
work. We
function.
don't want that,
Yeah, want to make
right?
a function.
We want a function like edge arity.
Mhm.
Yeah.
An edge arity should work on a graph and always return 2. Am I making sense?
Many twos for any
Many,
edge.
many 2s. Yes, many
Yeah.
2s.
Yeah.
Okay, great. All right, let's keep going. Hypermatrices. I don't know what the show is doing. We should just be able to return. What does adjacency matrix of a graph return? Of a hypergraph return?
Just a tensor matrix. There's an adjacency tensor and hypermatrix. There's like different things they do right now. Adjacency tensor.
Okay, so that
Adjacency
the hell
tensor
is
is defined in this Paclet.
Yeah.
Is that right? Does it work on graph objects as well?
No.
so
Good.
it obviously should.
But it
I mean, it
isn't
should.
that.
Okay, so adjacency tensor returns the sparse array,
Yeah.
whereas
And it has-
adjacency matrix of a graph generally does not return a sparse array, correct?
Well, it basically
What-
returns a list of those for each arity.
Yeah.
Oh, hold on. What? Yeah, I was talking about hypermetric.
Hypermatrix, that's, yeah.
Whoops.
Yeah, that's a hypergraph.
Hypergraph to graph them.
Oh, it does return a sparse array. An adjacency matrix does return a sparse array.
Right. It's just a representation, right? But
Yeah, it's fine. It's good.
Hmm.
Especially here when it has, look at all those dimensions. That's a crazy object in terms of, I mean, if I say input form %40 or array rules %40, lovely. That's magnificent.
Yeah.
Is it like normal? That would be horrible.
Yeah, I just did the normal. It was horrible.
Yeah.
Okay.
Question. Is the
Yeah.
sparse, is the adjacency tensor a flat array?
What do you mean?
No, it's
mean-
not.
I
It's
mean,
a
for-
deeply nested array, 7 by 7 by 7 by 7 by 7 array.
Right,
Yeah.
but is that because the arity of each of these hyperedges is 6?
The maximum arity is 6, yes.
Yeah.
Oh, okay. So it just embeds in the maximal.
And it also pads it. You see that there's like 7s in there. That's how you can tell from the position index which arity it is. Something. It's a bit hacky.
Yeah, it's
That doesn't sound right. That is
Wait,
not-
isn't
Thank you for
7
raising-
the vertex count? Isn't that where that comes
No,
from?
actually,
Six
the-
is the
No,
vertex
it's
count.
not. It's something very much weirder than that. Let's
It's
take
6
one of
plus 1.
these. Let's take one of these. Okay.
Mhm. Yeah, the hypermatrix of that gives you what right now is the adjacency matrix for the graphs. The adjacency tensor does something a bit
Okay,
more.
this is looking really weird. What the heck is the 7 doing?
Well, it's 6 vertices plus 1.
Yeah. So what this is, so let me explain briefly. So what this is trying to do is, in a hypergraph, you would have a array of order of dimension equal to the number of vertices, right? But you also have different dimensions for the different arities. So this was Nick's idea to basically be able to include all the information in a single array. Now, if you do hypermatrix instead of adjacency tensor, you would get the sort of arity-wise tensors. And in this case, you would get only one because it's only ternary.
But now it's some weird summary box there, right?
But from
So,
that
so
part,
it,
from that space array, can you reconstruct the hypergraph
Yeah,
Yeah,
from that one,
in
yeah.
a unique way?
yeah,
Yeah,
Except for tagging information,
yeah,
Right.
with all
Right.
the
just like with a graph.
so
Right,
is
it's
it or
completely unordered. No, it is ordered.
is it? Sorry, is it or is it not using the same kind of encoding that adjacency matrix uses for a graph? Kind of lost on that point.
Oh, it has to include some kind of additional information because you have to differentiate between different arities.
Yeah, so let's be clear. Let's be clear. Look at the array rules here, okay? What you would expect to find, let's say everything was arity 3. What you would expect to find is a bunch of left-hand sides for the array rules that are the specifications of the arity 3 hyperedges. Get what I'm saying?
Mm-hmm.
Now, let's say we mixed in there an arity 2 hyperedge. We don't have a way of saying in the sparse array, so, you know, that's our sparse array there, but let's say we also want the edge 4, 5,
I
right?
see.
We don't have a way to put that in there. So now the question is, how do we do that?
right.
I think
Okay.
a null vertex is, or an empty vertex is appended, so that's why 7 is there.
Yeah, that's what.
Yeah,
So
that's
basically,
1, 2,
comma 7.
0.
Yeah,
If you're trying
you
to
turn
pad
it
it
into
with
4,
a
5,
arity
7.
3.
So I understand. So there's an additional vertex that is essentially a dummy vertex.
Yeah.
Yeah.
That's being added into the array rules.
Yeah.
Is it a single vertex or additional ones for
Single.
each of the arities that you?
No.
No,
It's you just take the maximal arity. No, it's a. Oh, I see what you're saying. Is it the same vertex? If I had an arity 1 edge here
Mhm.
for arrow 1, would that actually be encoded as 477?
Yeah. Right.
Okay. Okay. So now the question is there any way? I mean, sparse array doesn't allow anything other than integer indices, correct, guys?
Other than what?
Integer indices,
Yeah.
right? So there's no way of putting, I mean, it would be lovely to have a none there or something. Do you see what I'm saying? Rather than a fake 7. Right, but we don't have an obvious way to do that.
Yeah.
Right, so that array rules will still work.
Yeah. The obvious way to do this with I mean, not with a single array, is this hypermatrix thing where you just go arity wise. And that's what the sort of hypermatrix output is, that gives you like a list of tensors. And
Okay, so what we've got, we could call it adjacency tensors, plural.
right.
Yeah.
I like that one more.
Yeah. I mean, the question here is also a bit mathematical and conceptual in that one thing is to extract the adjacency data and put it into array form. That's, I think, one thing that we should do in some way. And the other is maybe there is a natural object that is kind of the matrix analog for hypergraphs, which is something that is not really well understood mathematically.
Yes, I understand.
So that,
well, for mixed arity hypergraphs. I mean, for uniform arity hypergraphs, it's
right.
just a tensor.
It's just a tensor as we know it. Yes, that's right. But for mixed and mixed type and mixed symmetry and so on.
Let me remind you that in the case of a graph, a mixed directed undirected graph just blows away that information when you make the adjacency matrix. No, I'm sorry, that's not true. That's encoded in, sorry, I'm wrong. That's encoded in the adjacency matrix by whether the adjacency matrix is symmetric or not.
No, but
Right,
you're right. You're right that it blows it up if you put them together, because things just become edges and you don't know if it's the way you represent an undirected edge is with a symmetric matrix, and that will turn into could be understood as a two-way directed edge.
I see.
Right.
It could be two, there's no way to distinguish between a multi-edge that goes one directed edge goes in one direction, the other directed edge goes in the other
Exactly.
direction.
That's
for
right.
a single undirected edge.
That's right.
Yeah.
Yeah.
So what's the analog of that in hypergraphs? What's the analog of that for this? What is the thing that you would be specifying if you had a sort of a below, below par arity? If you understand what I'm saying.
No, I don't understand what you mean by that.
Well, I mean, let's say the par arity is 3, but you have a few arity 2 hyper edges.
Right. Yeah. I mean, what we do is the obvious of like just going arity wise and just listing the tensors per arity.
Yeah, I
And each
understand.
symmetry, you group by arity and symmetry. You can group by arity and symmetry for each of
Yeah,
those edges. You can
exactly.
make a tensor.
Yeah, arity and
Okay,
symmetry. Yeah.
But if
great.
you make a list of those things,
Yeah.
unless we have, I mean, we really want to be able to reconstruct the hypergraph from that list. And if we have a naked list without a wrapper, it's a bit tricky.
Yeah. Yeah.
That's why the hypermatrix has a wrapper. So it's a summary box which contains this grouping of tensors by arity and symmetry. That's
Right.
what it represents.
Exactly.
Okay. Whereas the adjacency tensor on its own has this kind of hack story in it.
Yeah.
Yeah.
Well, I mean, I'd like to know how one uses these things, because I think the mixed arity case is really rare.
Not really. I mean, if you're using hypergraphs, I mean, for data, this is actually the more common case. But for more,
Fair enough. Okay, but then we would like to know how you, in the mixed arity case, which of these representations is more useful. I mean,
Yeah.
it depends on what operations we're doing on the hypermatrices.
exactly. Yeah, exactly. So
For example, a good operation that we might do is what you would do with an adjacency matrix, which is to take powers of the adjacency matrix to
Hmm.
find, multi-step paths through the graph.
yeah,
Now, for hypermatrices, what would be the analogous thing?
the analogous thing is, sorry.
Go ahead.
Yeah, the analogous thing is basically the rewriting rules applied as what I call the one pass application, which basically you take a hypergraph, whatever that has its hypermatrix representation, then you build a hypergraph that is empty with the same vertices, and then you choose a hypergraph rewriting rule that takes some collection of connected edges and outputs a single edge on some of those vertices, and you just basically run that rule in every single match and keep only the output in the empty hypergraph. The result of that, if you do it for graphs, for pairwise graph, is exactly the power 2 or squaring of the adjacency matrix. So in general, for hypergraphs, you get some hypermatrix operations like ternary hierarchies and things like that. And it's really not obvious what the mathematics of that is. That's part of my work on those things. And the nice thing is that it's really quite well governed by this sort of hypergraph rewriting angle that allows you to have you don't really do this plex product thing. Allows you to kind of condense it into a single diagram of what you're doing, which is kind of how you're matching your vertices and your adjacency condition around those vertices, and that creates new hypergraphs of the same kind, which is like what you do with matrices. You have several matrices, you multiply them together, and you get matrices of the same kind. So there's an easy generalization that can be implemented quite directly with rewriting, where you generalize matrix operations and sort of this matrix calculus into arbitrary arities via these rewriting operations. But other than that, the story gets as complicated as people dealing with tensors and so on. It can get quite baroque. But there is one clear path where you can explain things via rewriting that is quite transparent, in my opinion.
Okay.
Yeah.
So basically, the concept of these matrices, absent hypergraphs and rewriting of hypergraphs, is a bit muddy. And I mean, we don't really know whether putting in these, the dummy node here that doesn't seem, in terms of powers of tensors, that seems pretty useless.
Yes.
It's just going to tangle everything up.
I like adjacency tensors.
Mhm.
And
But
have
then returning the same thing that we have for hypermatrix, basically.
Basically, I think so. Nick,
To
was
me,
it
Yeah,
that?
for this
maybe that's a
hypermatrix.
less daunting name for hypermatrix. I'm not familiar with the hypermatrix.
Well, especially hypermatrix would be one thing if there's only one of it, but by the time there's a whole gaggle of them, I think it's getting pretty weird.
Yeah, I think the name of hypermatrix is basically just playing on graph matrix hypergraph hypermatrix. That's the only kind of thing.
Yes, but so I suspect adjacency tensors makes more sense, and whether it needs an explicit wrapper or whether it's just a list of adjacency tensors, I'm not sure.
Sure, yeah,
I suspect a list of adjacency tensors will be a reasonable thing to do,
right.
because I think this is a kind of a minority operation anyway.
Yeah, yeah.
And it loses information in the sense of multi-set edges that have a vertex repeated
Exactly.
are not
Yep.
captured by that.
Yep, that's correct. Just like
What's
it
that,
is for,
Dugan? Can you say that again?
it's the same thing that we were saying for adjacency matrix, not capturing the difference between
Oh,
an undirected
right,
edge and two directed edges.
Right, yes.
What's in the summary box for hypermatrix? I'm curious. Okay,
Not too exciting.
fair enough.
Okay, so those are special hypermatrices basically here.
Yeah, just to show some. Yeah.
No, it's nice. I mean, we can have in the Paclet. I would absolutely have some special hypermatrices. My gosh, what is that creature there?
That's just the cubics 3D is just the.
I
Just thinking-
know, but I'm thinking just like we have matrix form, maybe we should have a thing that makes that. Do we have a WFR that makes that?
Sorry?
Do we have a WFR that makes this image?
Not yet. No, I don't think.
Okay, so I think we want to say, just
What do
like
you-
we have matrix form,
Cubics form, maybe.
that's amusing. I mean, yeah, for the WFR, why not?
Sure.
Does it give up at dimension 4? Or does it do something? Or
Gives up
rank
a
4?
dimension 4. That's why it's called cubics form.
Yeah. It's
No, show hypermatrix.
Oh, no.
What does it do for rank 4 and higher?
It doesn't do anything.
Okay.
I mean, yeah.
I
this
don't
one-
think this is particularly useful. I mean, I think that if you want this, you say adjacency tensors, and
Yeah,
then
yeah.
for the adjacency tensors, you just say matrix form and so on.
Yeah. No, this one was just to show the thing that, yeah.
Yeah, it's nice.
Yeah.
Okay, let's move on here. Okay. Let's just review a little bit forwards and then we'll come back to this, okay?
Yeah, now we have the header, so this is no longer that relevant because we already agreed that we are going to do a function that basically specifies symmetry. You get the graph, right?
Yes.
So yeah, that's there.
Okay.
And the thing there, I believe, is what Nick and I have been working recently, that we want to, the only meaningful update here is that we want to make the branchial graph and the causal branchial graphs into hypergraphs because they are naturally many groupings of things.
Yes.
And just add some options of what it counts as a link, as a causality link between events.
Yes,
yeah.
we should do that. I mean, those things were chosen for the physics project in a in a way that was convenient for that. I mean,
Yeah.
Just like we say branchial graph, we should say branchial hypergraph.
Right. That's one of the changes for sure. And the other change, just for your information, is that if you go down to the diagram there, you'll see that some of these events have overlaps on edges, right? Full edges are shared between the matchings. And other cases only have vertices as overlaps. So previously, vertex overlaps were enough to be considered causally connected. But in many applications, especially in this sort of mathsy, higher arity stuff, what you really want is edge overlappings and not necessarily vertex ones.
Good. Yeah, so we need some options.
So not so much. We're working on that right now.
Okay. I mean, I think this general idea of causality, and I mean, like Uti had written that paper about lambda calculus causality. I don't know if people have looked at that. Has
Right.
Nick looked at that by any chance?
Not really, not in detail. But I'm pretty sure you can, like, this compilation to hypergraphs can be done for lambda expression because it's like just beta reduction and rewriting of subterms. So it can be naturally embedded into this multi-way system with how it works.
Right. I would recommend that Carlos looks at Uti's paper
Mhm.
and perhaps gives him some feedback.
All right.
Because I take this point that you said it more clearly than I've understood it before, is whether overlaps can happen on a vertex or whether they have to happen on an edge.
Yeah, both are meaningful, and we need an option for that, I think.
Right. But I mean, the edges, the hyper edges are what we're considering tokens in the physics project, for example.
Mhm.
So, okay. Lovely. These look lovely.
Yeah.
Okay, let's come back to the rewriting stuff.
Yeah.
I suspect this is more complicated than what we're going to be able to go through here, because we also, let me just understand, whatever we're doing here, we also want to work for graph rewriting.
Oh yeah, graph rewriting is a total subcase of this.
Is it, with all the DPO insanities that people have invented? I mean, I used to call those things, I call them hairs back in the early 90s. But that, independently turned into all this DPO nonsense.
Right. So we are doing in some sense, a very special kind of rewriting, but in the current way that we have the Paclet, as far as I can tell, this is as general as it gets. Like, it gives us all the flexibility for say, if you want to treat hypergraphs as kind of pure objects that are just the combinatorial entities they are, or if you want to use them as diagrams and label them and use them as expressions, it gives us, we need some options, of course, to control of that. But for now, and this does correspond in some technical sense to like DPO and so on, but we are not being bound explicitly by that. I'm not like going to my textbook and checking that, this is DPO complete and there's a factor or anything like that. Like we do it because it allows us to do all the cases. So for example, I benchmarked against the recovering matrix multiplication just by rewriting. That to me is a very important benchmark, right? That you can just say, I can take the adjacency matrix, multiply them, get a new matrix, then take the graph, or I can just go through the graphs by rewriting, because we can do that in a very sensible way that is kind of nice. I think we are on the right path. And so we are generalizing from that. And yeah, so everything else, but it's a subtle thing. Rewriting is a subtle thing, because you have things. We are now thinking about options for how you want to consider the cases that you matched. So for example, in directed hypergraphs, they are very structured, so it's quite simple because that things are quite rigid. But for example, if you have an undirected hypergraph, and you want to match,
can I ask, do you mean properly undirected and directed, or unordered and ordered?
Oh, sorry, yes, unordered. Sorry.
Okay.
Unordered. Yeah. I should have said that. So unordered. I think if you scroll down, there's an example of an unordered rule.
Okay, listen, look, hold on. I just want to make several points.
All right.
This whole kind of thing, specifying a match. We've got at least 3 cases where we need to do this. One is pattern matching, where we've never had this kind of disgorgement of the details of how the match happened. Another is find equational proof. And the third is these graph rewritings. Oh, making sense? I mean, find equational proof has a version of specifying where the transformation was done.
Yeah.
So we need a uniform way to represent.
Trace graph is maybe in this category.
Yes, the WFR trace graph is another example of this. So it's like not just what happened, but how it happened. Am I making sense?
Yeah.
For everything here, when I used like, I only have a single source for this kind of thing right now, just this multi-replace function, which is in the repository. This is what I use when I want to disgorge all of the matching information about the replacement and do it in all possible ways that I know of.
Okay. I think we should look at that. I think a separate meeting for multi-replace. Okay, but given multi-replace, this looks comparatively, I mean, I'm assuming that given multi-replace, this is reasonably straightforward. Is that true?
Well, that's in fact what I'm using under the hood here.
Well, I realize that, but I'm saying if you can specify, okay, question, in the physics project, hypergraph rewriting is well defined. And I think, I mean, it's that was one of the innovations between what I did in the 90s and what we did, 4 or 5 years ago, was the much easier specification of hypergraph rewriting as compared to graph rewriting, because of the dealing with dangling ends and so on. But
They have to have different language design, right? You wouldn't want in graph rewriting to allow rewriting into a hyperedge.
no, I understand that. But the problem with graph rewriting, let me give you a typical example of the problem. With graph rewriting, you can say a single node, for example, turns into this non-symmetric, let's say a single node in a trivalent graph turns into a non-symmetric graph with 3 hairs on it. See what I'm saying?
Yeah.
And that thing is no longer that thing. Either you do, you can do what
it's like raw material for graph rewriting, but it's not like a finished graph, right?
Well, no, but no. The issue is if the symmetry is lower on the right-hand side, then it's kind of like a version of /dot or something. You have to pick one of those symmetry configurations to actually do the rewrite. Making sense?
Yeah.
But it's yet another twiddle in how this all works. And the actual rewrite, here's one of the issues. The rewrite rule is not itself a graph. The rewrite rule is a graph with hairs.
Right.
Yeah.
Whereas with hypergraphs, the rewrite rule is itself a hypergraph to hypergraph transformation.
I'm not seeing a difference. I'm not seeing what hypergraphs get you from graph for that difference.
Let me think. The issue is, let's see, there's a whole issue with hairs and where the hairs connect into the existing graph, which for some reason doesn't exist for hypergraphs, and I'm now forgetting how that actually works.
But I think if you're thinking in terms of hairs, I think you're already kind of using a way of rewriting. I think in both, I mean, hypergraph, the way I understand hypergraph rewriting definitely subsumes graph rewriting, and the specification is, as you say, 2 hypergraphs, and the fact that you're doing a rewriting which effectively corresponds to saying what is preserved and is common between the 2, right? So maybe there's like 3 hypergraphs in some sense, like input, output, and what's preserved.
I think we need a separate meeting to discuss this.
I think so too. I was going to suggest that the rewriting is much more subtle, and there's a lot of.
And we didn't solve it for graphs yet. I mean, we've been talking about it for graphs for years. I mean, Charles, you haven't had any particular plans for that. Is that true?
Actually, is one of the projects in the plan for the coming release. So we are kind of starting to explore and
well, okay.
And
So we should, we know lots about graph rewriting, or at least hypergraph rewriting from, for example, the physics project. So, and the various projects that have been done around graph rewriting, I think we should know all of the characters involved in that. So that's something, okay, further discussion. 2 things, multi-replace and graph rewriting are 2 things that need subsequent meetings. They could be tried to be in the same meeting, but I think they're going to end up being slightly separate, but not completely separate.
Yep.
That makes sense to people?
Yeah, sounds good.
Sure.
Okay, but so what we've got here is something. I mean, this Hypergraph Paclet is already out in the Paclet repository, isn't it?
Yeah, you
Okay.
just installed it from there.
Okay, fine. So this is just a revision with design cleaning.
Mhm.
Okay. And Charles, I think we should be thinking about, whether we can use this stuff in a subsequent release to include hypergraphs as a built-in system capability.
Yeah, definitely. That's why I've been looking at that Paclet and
Okay,
definitely
fine,
use that.
fine. But I mean, good stuff.
Mhm.
All right. Anything else for this meeting? Otherwise, this is looking really nice. It's good work.
Thank
I
you.
don't know if Charles wants to comment on it anyway on any of this and its relation. I mean, okay, here's a question. All the functions that we have for graphs, who's gone through and inventoried which ones are possible for hypergraphs?
We did that at some point long ago. I did at least, and I made a list. But
Can we make
we
sure
did try to get as many as possible with the same names and so on.
Okay. So I mean,
But this
there's
was a
like,
while ago, so doing this again might be relevant, actually.
I mean, graph data. We might want a hypergraph data because graph data is kind of common graphs. Complete graph. We might want a complete hypergraph, possibly, although it's not so clear what that means. Highlighting.
Are there hypergraph file formats to import?
I doubt it. I think we might make one. Maybe we should make one. Did we have one for the physics project? I'm trying to remember.
None that I'm aware of.
One thing that makes an object interesting if there's a variety of way to create or get that object. And so I'd say, like for graph, 1/3 to half the functions are ways of creating graphs from all kinds of ways.
Well, that's
So
construction.
Yeah, I think that's a good thing for hypergraphs, because any natural data often is more naturally a hypergraph than a graph. Like most human data is like many groupings and things like that. So
Well, so the question is, so that's the thing to look at, is whether these functions, like for example,
and it
does
took
tabular lead to a hypergraph? Can you get a hypergraph from a tabular? Bet you can.
and also, I mean, we even
Every row is a sorry, Roger, go ahead.
Version 1 of graphs, we came up with all these ways of getting graphs from entities and import elements and all kinds of things, but we couldn't get it done. But once we had it out, we got, people would start listening to us, even though we wrote prototypes and other things. And then people started aligning with graph. And so then it gained momentum. So that there is a gazillion places to find it. And there's many more for graphs to do as well, because often you generate them from data in some way.
Right. I think group data of various kinds naturally leads to hypergraphs, and we should look at how to do that.
yeah, exactly. Yeah.
I mean, like a chemical is more like a graph.
Or any mesh, like you can turn meshes into hypergraphs. But now we can actually take polygons into hyper edges.
Exactly.
And I think tabulars are, when you convert them to hypergraphs, the rows are the hyper edges, and the number of columns is the arity.
Right.
Well, and so that means we might want tabular of a hypergraph to do something interesting. I don't know, but
at least hypergraph of a tabular.
I think you should focus on making the sort of hypergraph world rich.
Yes. Well, and I mean, we just look through here. I mean, like relation graph. I suspect there's a relation hypergraph that's meaningful.
Absolutely. You could do, k-array relations.
Yep.
Yes.
Yep.
Yeah, exactly.
That's one that seems worthwhile.
Nest
expression
hypergraph.
What's that?
Nest hypergraph. I don't know what it even do.
How the heck do you do that?
I don't know.
How do you do that? Because a nest graph has a notion of time going from one. I mean, there's a time-like edge.
Well, the function is applied to a vertex and gives a list of new vertices and edges connect from the old ones to the new
Right,
ones.
and there's, I
I'm
see.
not
So
sure
what
what
you
to
would
do
do,
for nest
no,
hypergraph.
I tell you what you would do. Instead of those all being from a single node to a collection of nodes in you know, that's the front, so to speak. That the front could be hyperedges.
Yeah.
Yeah. You just keep adding hyperedges.
Right. I bet clustering tree could do something. Clustering could definitely do a hypergraph play.
Well, clustering tree will be replaced with dendrogram tree in the next version, not 14.2.
Right.
Yeah.
Okay, so there are a few things, but I suspect that there are indeed data groupings that will naturally, you know, anyway, that's that. We've got isomorphic hypergraph queue, presumably. Do we have isomorphic hypergraph
Yeah.
queue?
We do.
Yep.
Hypergraph distance
Not really,
and
but there's
pathfinder.
some in the repository, right?
This is tricky. Doing generalized paths on hypergraphs, it's I mean, there's a way of doing paths just like in graphs, but generalized paths is not so easy.
I didn't know about graph density. What is that? Oh, I should have used that a bunch of times. I didn't know that existed. And it's more than a decade old. Grumble. I didn't pay attention to these. Well, okay. Anyway. You know, by the way, when we have things like mean neighbor degree, we should really put in the measures that we used from the physics project for dimension of geodesic balls and so on. We have this neighborhood. There's a bunch of function repository functions, which we really should include for as basic graph functions. They basically take geodesic balls and they're looking at properties of, you know, from every geodesic ball, they're looking at the number of nodes you get to as you go outwards in a geodesic ball. Anyway, that's probably an ILD thing to discuss. Not too difficult. What's that?
Hausdorff
Yeah, it
dimension?
eventually gives a, well, it's not quite the Hausdorff dimension, but eventually gives something like the Hausdorff dimension from its growth rate.
Jonathan called it Wolfram Hausdorff dimension. That's the name of the sharp function.
Yeah,
I
we
know.
did.
I mean, because that was the thing that, I mean, I started using that in the early 90s, and it didn't seem, the things that people had used for dimension were much more Baroque than that. It's a very simple version. All right, well, look, some more work to do, but this is clearly on a great path. I don't think social networks are quite in hypergraphs yet, are they? I don't really know.
Easily turn into hypergraphs. There's a lot of people doing that.
Community plot is basically a hypergraph.
Yeah. Yeah. I mean, any community-like analysis of graphs also lead to hypergraphs naturally.
All right. Well, that will be a useful thing for the Hypergraph Paclet in general, just to look at, you know, common applications of hypergraphs and see what kinds of ways people want to get them in and out.
Yeah, that's definitely on our roadmap. Like I have a bunch of a list of applications that people are currently doing that will ensure that if we have a nice function set of hypergraphs, people will basically use it because they are
Sounds
already.
good. Sounds good. All right. Nice work.
Thanks,
Any further comments from anybody?
We good?
Looks good.
Okay. Thanks a lot, guys. See y'all
All right.
soon.
Bye.
Bye.
Bye. Bye.